All right, hi folks, this is Larry Mussolino. I wanted to record a video to help with Objective 1 in Math 26. And Objective 1 has quite a few factoring questions, and factoring is a challenging concept. Let me give you a little background, and then I want to work through some of the ALEKS topics that seem to be causing a little trouble, and then hopefully this will help you work through Objective 1. All right, well, first let me explain what is factoring anyway. Well, when you think about factoring, it's really asking you to rewrite some expression as a multiplication. So when you talk about factoring, it's really asking you to rewrite an expression as a multiplication. We'll give you a simple example involving numbers. What if I asked you to factor the number 15? Well, that's just asking you to rewrite 15 as a multiplication. I could write it as 3 times 5. So this idea of taking an expression and rewriting it as a multiplication is what we mean when we say factor. So let me give you a simple example of factoring. But before I do that, I want to remind you about multiplying, because factoring is really the opposite of multiplying. So before we can factor these expressions, we have to kind of go back and revisit multiplying. Let me give you an example of multiplying two parentheses. How about if I have x plus 3 times x plus 4? Well, you might remember when you do this kind of multiplication, you have to use what's called a FOIL multiplication. And all that means is to do this multiplication, start out with this first quantity here in the first parenthesis, x, and let it multiply each quantity in the second parenthesis. So I'm going to take this x and let it multiply this x. So that's going to be x times x. Then this x also has to multiply the 4. So I'm going to add that. That's going to be 4 times x. Then I come back and do the same thing for this 3. The 3 is going to multiply that x, so that's 3x. And then this 3 is going to multiply that 4. And now I can just clean this up. X times x is x squared. 4x plus 3x is 7x. And 3 times 4 is 12. Okay, so we just multiplied these two parentheses. Now let's work backwards. How about if I asked you to factor x squared plus 7x plus 12? Well, we've got to reverse the steps we just did. So when I go to factor this, I'm going to try to set it up as two parentheses. All right, now this is a little bit of like a logic puzzle. I know I should put an x and an x in front of these parentheses because I need an x times an x to get me back to this x squared. Now, here's the question. What two numbers should I put in these boxes? Well, I know that when I take that 3 times the 4, it got me this 12. So what that means is the number in box A, I'll call this box A, I'll call this box B. The number in box A times the number in box B has to get me this number 12. But notice these two numbers, 4 and 3, added to get me this middle term of 7. So what I need then to figure out this factoring problem is I need two numbers that have to multiply to get me 12, because that's this constant out here. But then they also have to add to get me this middle coefficient here of 7. So now I have to do a little bit of thinking about what two numbers would multiply to 12 but add to 7. Well, when I think about numbers that multiply to 12, the only options I would have are 2 times 6, 3 times 4, or 12 times 1. But there's only one choice where the numbers add to 7. That's this 3 and 4. So that's how I know to put 3 and 4 in these parentheses. Okay, so to do this factoring process, you really have to think about reversing the steps you used from this kind of a FOIL multiplication. All right, so with that, let's go to this example that says factor completely. And they're giving me this expression, 4x squared minus 36x plus 7. Well, it turns out that the first step in factoring is to always check for what's called a greatest common factor. And I'm going to look at these numbers. Notice I'm seeing a 4 and a 36 and a 72. Is there any number, think of a number, that can evenly divide into all three of those numbers? If you can come up with that number, that's called the greatest common factor. So I'm looking for a number that can evenly divide into 4 and 36 and 72. The number's got to divide into all of those numbers. Well, it turns out the greatest common factor is going to be the number 4. So what we could do is we could pull that 4 out in front and see what's left over. Well, if I take a 4 out in front, it's going to leave me an x squared here. All right, now 4 times what number would get me back to the number 36? Well, I know it's 4 times 9 is 36. I'm going to put a 9 there. And then in the back here, 4 times what number would get me 72? It turns out 4 times 18 is 72. So what I have is 4 times x squared minus 9x plus 18. All right, so let me try to figure out how to factor what's inside the parentheses. Okay, so I know I'm going to need an x and an x in front to get me back to this x squared when I multiply. All right, now I need two numbers in these boxes. Now these two numbers have to add to get, have to multiply to get me 18, but then add to negative 9. Let me write that over here. So the numbers have to multiply to 18, but add to negative 9. All right, let me think about the signs. Should these numbers be both positive, both negative, one of each? Well, I need the numbers to multiply to get me a positive number. Well, for two numbers to multiply to get you a positive answer, the numbers would either both have to be positive or both have to be negative. But I need them to add to a negative 9. The only way that's going to happen is the two numbers must both be negative. If the numbers are both negative, they could add to negative 9 and they could multiply to 18. So let me think of numbers, two numbers that would multiply to 18. They have to be negative. Well, I could use negative 3 and negative 6. I could use negative 2 and negative 9. Or I could use negative 1 and negative 18. Those are my choices. But I need the numbers to add to negative 9. Well, the only option that would add to negative 9 is the choice negative 3 and negative 6. These others will not work out. So that means I'm going to put a minus 3 and a minus 6. That's the answer to this question. So the answer here is 4 times x minus 3 times x minus 6. Folks, for any of these factoring problems, you can always check your answer. The way you could check your answer is re-multiply back through the parentheses. Do a FOIL multiplication. And you should end up back to the starting expression. If you don't end up back to the starting expression, that tells you that you messed up a little bit. All right, let's do another example here. How about if we take a look at this example? All right, now there's another factoring method that we can use here because they're asking me to rewrite the expression by factoring out the parenthesis u minus 2. Let me give you an example before we get to this one. How about if I had 7x to the third minus 5x squared? You might notice here I can factor out some of the x's. And when you go to factor out a variable, you factor out the smallest exponent that appears. So I'm noticing there's an x to the 3 and an x to the 2. Well, the smallest exponent is the x to the 2, so that means I can pull it out in front. And if I factor out an x to the 2, I'm going to be left with 7x minus 5. So notice we factored out here a greatest common factor. And you might say, well, how did you know to put a 7x here? Well, what I said to myself is, if I was to take x squared and multiply it times some quantity, what quantity would I need in this box to get me back to 7x to the 3rd? And in the back here, what quantity would I need so that if I multiplied x squared times this quantity, I would get back to 5x squared? So that's how I figured out what's left over to put back in these parentheses. Well, in our example, we could do the same thing of factoring out a greatest common factor. The only thing you got to recognize here is there's actually this parenthesis u minus 2 that's in common between the first part and the second part in this expression. So what that means is I could take this u minus 2 and factor it out in front of the parenthesis, just like we factored out this x squared in front. So I'm going to do that. I'm going to take a u minus 2 out in front. Well, if I take this u minus 2 out in front, what's left over here? Well, it looks like a 3u is left over. And what about if I take this u minus 2 in front back here? Well, it looks like there's just a minus 5 left over. Okay. And again, this is factoring because notice we've rewritten this as a multiplication. It's one parenthesis multiplying a second parenthesis. So that's how we accomplish the factoring. So for this example, what I had to recognize is there was this u minus 2 in common that could be factored out. All right, I'm going to go to a couple more. How about if we look here at something called greatest common factor? All right, so they're asking us here to find the greatest common factor for these three expressions. All right, well, what I want to try to do on this one is look at, I'm going to actually do another example and show another example. And I'm going to make up my own example for a second, then I'll come back to this one. I was looking for an example that had a variable as part of the greatest common factor, but I'm going to make up my own example. All right, let me do it. How about 4x to the 5, 16x to the 9, and 20x to the 3. All right, and the question here is find the greatest common factor. I'm going to break this up into two parts. The first part is look at the numbers only to begin with. All right, well, the numbers are 4, 16, and 20. Well, you know, when you're finding a greatest common factor, you're looking for some number that evenly divides into 4, 16, and 20, but you're looking for the greatest number. Remember, this is greatest common factor. So you might say, well, wait, 2, the number 2 evenly divides into 4, 16, and 20. Well, that's true, but it's not the greatest number you can come up with. The greatest number is the number 4. Because the number 4 can evenly divide into the 4, into the 16, and the 20. I can't come up with any larger number than that. All right, now I'm going to look at the letters or the variables. So I'm noticing there's an x to the 5, an x to the 9, and an x to the 3. Well, for the variables, you want to factor out the smallest exponent you see for each letter. Well, the smallest exponent I'm seeing is x to the 3. So that's the greatest common factor for the variables. Now, the overall greatest common factor is putting these together. So the answer to this example would be 4x to the 3rd. All right, so let's go to this example. So let me do it in the same way. I'm going to break it up. Let me look at the numbers to begin with. Well, if I look at the numbers, I'm seeing a 49 and a 63 and a 21. So I'm asking myself the question, what number can I come up with that evenly divides into all three of those numbers? And I'm looking for the largest such number. Well, you might notice number 7 evenly divides into all of those. All right, now let me look at the variables. Now, for me to be able to factor out a variable, I would need the letter x to show up in all of the terms. So I'm noticing there's an x squared here and x to the 4 here, but no x with the 63. Well, if x doesn't show up in all three of them, all three of these expressions, I can't factor out an x. So cannot factor out an x in this example. So the answer to this question is just the number 7. Okay, so this is factoring, this is identifying what is a greatest common factor. All right, let me do one or two more examples. Let's turn to something called, all right, let's take a look at this one. This one's a little tricky. And notice the tricky part of this is there's actually 2 letters here. So in this example, there's 2 variables. You can see there's an x and a y. All right, well, to factor this, I'm going to try to factor it as 2 parentheses. All right, well, I know in front, I'm going to need 2 quantities to multiply to get me x squared. So I'm going to put an x and an x in front. All right, now, let me go to the back here. You might remember whatever is in this box and whatever is in this box, these have to multiply to get me 9y squared. So that means I need a quantity in back to multiply to get 9y squared. But also, what's in the middle I have to add to get me negative 10xy. Well, what it means is in the back here, I'm going to need a y. I'll call this box A and box B. Because I need to end up with a y squared when I do the multiplication, that gives me a hint that I'm going to need a y in box A and a y in box B. All right, let me try to figure out the signs. Well, I'm noticing that they have to multiply to get me a positive, but add to get me a negative. Well, the only way you can get 2 quantities to multiply together and give you a positive answer, but at the same time add together to give you a negative result, 2 quantities have to both be negative. So I know I've got to put 2 negative signs here. All right, well, when I think about 9y squared, I could either use negative 3y and negative 3y, because negative 3y and negative 3y would multiply to 9y squared, or I might have a negative y and a negative 9y. Because again, those would multiply to get me positive 9y. But remember, I'm going to need these to add to get me a negative 10. Well, the first one is not going to work out because those would add to get me a negative 6. But this one, if I put a negative 1 here, just to make it a little more obvious, would work out to be a negative 10. So I'm going to put a negative 1y and a negative 9y in the back here. Let me do a quick double check. Let me write this here. So we got x minus y and x minus 9y as my possible answer. Let me do a quick FOIL multiplication because now I want to do a double check. So this is going to be a check. All right, I'm going to start out with x multiplying x. That's x squared. Then I'm going to do x times negative 9y. That's going to be negative 9xy. All right, then I'm going to come here. This minus y is going to multiply that x. So that's minus xy. And finally, I'm going to have a negative y multiplying a negative 9y. That's plus 9y squared. These two terms here in the middle are like terms. I'll combine them. That gets me negative 10xy plus 9y squared. It looks like this does match the starting expression. So that convinces me that my answer here was correct. All right, folks, so this example is a little more complicated because it involved two letters. But when we had two variables, I put an x in the front and a y in the back, and that ended up giving me this quadratic expression that had two variables in it. All right, let me do a factor by grouping problem. All right, folks, let me talk about another type of factoring. So, you know, the example we did a little earlier, we factored x squared plus 7x plus 12. You might remember when we did the factoring on this, we got x plus 3 times x plus 4. And the way we came up with this is we kind of worked backwards from a FOIL multiplication. But notice in this example, we have three terms. Right, here's the first term, here's the second term, and here's the third term. So this method we talked about is applicable when you have three terms. But notice here we have, in this example, we have four terms. Right, here's 1, 2, 3, 4 terms. So I'm going to use a slightly different method here. It's called factor by grouping. Okay, and what this is going to do is kind of lead us to a factoring example like this. Let me give you a quick example. Let's say I had x times x plus 7 plus 9 times x plus 7. And let's say I want to factor this guy. Well, you might remember we did an example like this a little bit ago. What I noticed here is this x plus 7 is in common for the first part and the second part of the expression. What that means is I'm going to pull that parenthesis x plus 7 out in front. It's kind of like factoring out a greatest common factor. If I do that, I pulled out this x plus 7. That leaves me an x here. And I pulled out this x plus 7. That leaves me a 9 back here. So this would be my answer. So that's what we're going to target. We want to get our problem to look something like this example. And then we can pull out this parenthesis, x plus 7, because it was in common from the first and the second part of the expression. Well, here's the way I'm going to do this. To begin with, I'm only going to look at the first two terms only. And I'm going to try to factor what's in the blue box to begin with. All right, let me do that. I'm going to factor what's in the blue box. Well, I'm noticing the number 10 and the number 4. What's the largest number that evenly divides into 10 and 4? Well, the number 2 can come in front. All right, now let me look at the letters. I see an x to the 3 and an x to the 2. Well, remember, you factor out the smallest exponent you see. That means x to the 2 comes out in front. All right, so now let me see what's left over. 2 times some quantities got to get me back to the 10 here. Well, I need the number 5 there. Okay. X squared times some quantities got to get me back to x to the 3rd. That means I need an x here. Okay, let me go to the back. 2 times some numbers got to get me to 4. That means I need a 2. And x squared times something's got to get me back to x squared. Well, I don't need anything then with the 2. So I just factored out the greatest common factor from the first two expressions only. Now I do the same thing, but I look at the back two expressions only. All right, let me look at the back two. First, let me check the numbers. There's a 15 and a 6. Well, you might notice 3 is a greatest common factor. So I'm going to pull a 3 out in front. If I pull a 3 out in front, then 3 times 5 will get me back to that 15. And in the back, 3 times 2 will get me that 6 that I need. All right, so I just factored the last two expressions, and it turned out 3 was the greatest common factor. Well, let me go one more step now, because notice this parenthesis, 5x plus 2, is in common in the front and the back. So I'm going to pull this guy out in front. So I'm going to pull out a 5x plus 2. Well, what's left over? If I take this 5x plus 2 out, there's a 2x squared left here. And if I take this 5x plus 2 out in front, there's a 3 left back here. So this is the final answer. Okay, so we call this factor by grouping. And you use this when you see 4 terms or 4 expressions. And the way you do it is look only at the first 2 expressions to begin with. Look for greatest common factor, then separately look at the last 2 terms, do the factoring on that, and you may end up with this parenthesis in common. Here, our parenthesis in common was 5x plus 2. Once you see that parenthesis in common, you can pull that out. All right, maybe I could do one more. Let's see if we did this one. This one we did already. This one I think we did already. Let's do this one. This is another factor by grouping. Let's do one more here to get a little more practice. All right, so again, the way I'm going to think about this is, because this is 4 terms, I'm going to try to factor only the first 2 to begin with. I'm going to write this over here to make it a little easier to work with. W third plus 2w squared plus 7w plus 14. All right, so I'm going to try to factor just these first 2 expressions to begin with. All right, well, I'm noticing there's a W2 that's in common, so I'm going to pull that out. Well, W2 times what would get me back to W to the third? So I need a W here. W to the 2 times what would get me back to 2W to the 2? I need a 2 back here. All right, now I'm going to turn to these last 2 expressions, 7W plus 14. Well, I'm noticing there's a 7 in common that can be factored out. If I factor out a 7, I'm left with W plus 2. Now I check and see if the parenthesis is in common, and yes, it is. Here's a W plus 2 parenthesis. Here's another W plus 2 parenthesis. So I'm going to factor these out in front. So let me pull out the W plus 2 parenthesis in front. If I do that, I'm left with a W squared here. And in the back here, I'm left with just the number 7. So this is the final answer for this problem. Okay, again, this is called factor by grouping. Okay. Let's see, I think we did one like that already. I think we did one like that already. All right, folks, why don't we do one more quick example here? It says multiplying binomials with negative coefficients. All right, so this one's really asking you to do like a FOIL multiplication. Remember, folks, whenever you need help with Alex, click on this explanation button. And notice this explanation button will help you with step-by-step, okay? All right, well, let's work through this. Now, you know, anytime you multiply expressions together, you can multiply in any order you want. Let me give you an example of what I mean by that. Let's say I'm multiplying 2 times 3 times 4. It's really up to me. I could multiply the 2 times 3 to begin with, or I can multiply the 3 times 4 to begin with. The order doesn't matter. You know, in this first example, if I multiply 2 times 3, that'd be 6. 6 times 4 is 24. In this example down here, if I multiply the 3 times 4 together, that'd be 12. 2 times 12 is still 24. So the order doesn't matter. So how about if I multiply these two parentheses together first, then I'll multiply by the -5 at the end. I don't have to do it this way. I could take that -5 and multiply inside one of the parentheses, but it might be a little easier to do this FOIL multiplication to begin with, so let's do it. All right, I'm going to take this A and let it multiply that A. I'm going to bring the -5 down with me. But A times A is A squared. All right, now I'm going to let this A multiply the 2 in the back. That's 2A. All right, now I'm going to come back. I'm going to think of this as a -3 and let that multiply the A. So that's -3A. And finally, that -3 multiplies the 2. That's -6. All right, now let me just combine like terms inside the parentheses. I have a +2A and a -3A. Well, that's -1A. I could just write that as -A. All right, I'm down to one last step. I'm going to take this -5 in front and let it multiply inside the parentheses. You might remember this is called the distributive property. All right, well, how about -5 times A squared? Well, that's -5A squared. Then I have a -5 times a -A. But that's a negative times a negative, which is a positive. So that's +5A. Last multiplication, -5 times -6. Again, that's a negative times a negative, which is positive. So that's +30. That's the final answer. I can't do anything else to simplify this answer. There's no more like terms. So I know that's the final answer on this one. All right, folks, hope this is helpful. If as you're working in Objective 1, please email me if you get stuck, and I'll be glad to help out. Also, remember that there's tutoring available. If you go into Blackboard, there's a schedule for tutoring that I posted. So please feel free to make use of that tutoring help as well.